about section 2.8, and we're going to start with example 1. And we're asked to prove that sine of x equals 0.3 has at least one solution. What we're going to use is the intermediate value theorem. So we need to have a continuous function. We know that sine of x is continuous. There's no breaks, and it goes, forever in both directions, no breaks. So what we're going to do, we need to pick two values that are easy to work with sine, that we know this is in between. So two that come to mind for me, 0 is definitely less than that, and then pi halves, which would be approximately 1.5. Okay, pi halves is easy to work with on sine. So if we look at basic sine function, pi halves is right here, 0 is here. This is 1, down here would be -1. So if we just look at sine of 0, we know that that's 0. If we look at sine of pi halves, we see that that is 1. And since we know it's a continuous function from 0 to 1, we know that it's going to hit every value in between 0 and 1. So by the intermediate value theorem, we know that there will be at least one place where it's equal to 0.3. All right, example 2. So it says show that cosine squared x minus 2 sine x fourths has a 0 at 0, 2. The location, then locate the 0 more accurately using the bisection method. Oh, sorry, this is an interval, it's not at. So in between 0 and 2, show that there's a 0 somewhere in between there, and then use the bisection method to find it more accurately. So we could just use the intermediate value theorem first. We know that this continuous function minus this continuous function is still a continuous function. And so if we plug in 0 for all of this, which that's really just sine of 0. Okay, so cosine of 0 is 1, 1 squared is 1, minus 2, sine of 0 is 0. Okay, so that's just 1. And then if we plug in 2, we get cosine squared 2 minus 2 sine 2 over 4. Okay, now if I plug this into a calculator, I get negative 0.786. So the only thing that we really care about is that the first one was positive and the second one was negative. So if this is a continuous function, we know that if you're going from positive to negative, at some point you had to cross a 0. So that's all we need to prove that there's a 0, or is that even the word they used? I can't. Yeah, so it has a 0. There's other names for it, that's why I was wondering. There is a 0, or it crosses the x-axis somewhere between 0 and 2. Now, what we want to do is figure out where it could be. And so to do that, we're going to cut this interval in half and test it, because we know, basically, let's look at this. So for between 0, let's do a number line. So for between 0 and 2, we know we cross somewhere between these things. Now if we just look between 0 and 1 and we get a positive and a negative answer, just like we did, then we know it's now there, and then we can cut it in half. Now if it's not there, then we know it's here, and then we can find it more exact. So let's try that. So we already know 0 is positive. Now if we plug in a 1, if we do cosine squared 1 minus 2 sine 1 over 4, if we plug that into a calculator, we see that this is also negative. So now we know that we're in this section. Now if we want to do it again, now we can test 1/2. Plug it into a calculator and see if it's on this side or this side. Now, this actually gives us a positive answer. So now we know that we're in this area where this is 1/2 and 1. Now, we could do it one more time to figure out. We would go 1/2 to 3/4 and see which side it's on. I'm not going to do that, but based on a graphic in the book, we know that it's somewhere between 3/4 and 1. And you could do this to infinity and theoretically figure out where it is. It's not very efficient, but it does give you can scale it down and eventually find that. If you need additional help, please come to Math Lab. Until then, calculator.